Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to talk about Sparklines. Sparklines are a new feature that recently appeared in Power BI, and it's just super cool. Instead of showing just numbers, you can show a line chart or a column chart in any cell of a matrix or a table. And it's so beautiful that everybody started tweeting and using Sparklines in their reports. Now, I'm a DAX guy, so from my point of view, the most important and interesting part of Sparklines is how they are implemented. What kind of queries are generated in order to reproduce a Sparkline? Because as soon as you start using a Sparkline, the number of points that you need to gather for a matrix increases by a lot. Therefore, the query needs to be more complex. And that is the reason why, as soon as Sparklines hit the market, I immediately opened Power BI Desktop, I created a Sparkline, and I tried to understand the kind of DAX code that was there. And you can be assured that at the very same time, Marco was doing the same. So in two different places, we were just looking at the code, and we had the feeling that the DAX code is really bad. It doesn't look good DAX code because it takes a lot of formula engine, and the technique used to implement Sparklines didn't seem so bright. So we start chatting about the topic, and while chatting and while discussing other possibilities, we quickly discover that actually the implementation is quite good. It's a good way of implementing the gathering of the data required for a Sparkline. So after this very quick investigation, I decided to go deeper and try to beat the code of a Sparkline. So this is the topic of this Unplugged. I have not yet done this, so it's completely new, and you are not going to learn anything because I actually don't know what I'm going to do. What we will do is create a Sparkline, grab with Performance Analyzer the DAX code of the matrix that contains the Sparkline, and then we investigate on it. We'll try to understand the choices made by the development team during the creation of this DAX code, and then we try to make it faster. I have no idea whether we will be successful or not. Let's get started. This is just our Contoso model, and I have a matrix that is already slicing by brand, by product, the sales amount. I'm using product because I want a lot of points, so I want a lot of rows in my matrix because I want performance to be, not performance, I want the query to be quite slow so that we can actually check performance. Then we add a Sparkline. So we just need to go here and add a Sparkline. We project the sales amount and we do that by date. Let's go for year month, and then we create it. You see, I now have the Sparkline. Now, the first important point to notice about Sparklines is that the number of points in the query needs to be much larger. Let me explain that a bit better. Before, we had just this set of data. So for the product, we have the sales amount, and we consider this as being 1 point of the query, one value that needs to be represented in the query. But the thing is, with a Sparkline, the number of points increases by a lot, because now for one individual product, each of these values is actually 1 point. So the number of rows that needs to be gathered from the Power BI engine in order to produce the Sparkline is much larger than the number it was here before. Let's say we have 100,000 rows here. That means 100,000 points. As soon as you add a Sparkline, each of these points will be multiplied by the number of values that you are projecting in the Sparkline. That increases in a massive way the number of values that needs to be gathered. Then you also have, with Sparklines, the capability to change some properties. So you can decide, for example, to change the chart type to line or column, or use markers. Markers are interesting. You can mark, for example, the lowest, the highest value, and stuff like that. Let's mark the highest and the lowest value just to have more points. And you see that now the points are more visible. We have the highest, we have the lowest, and each of these is a point. So time to go deeper and understand the kind of query generated. So let's launch the performance analyzer. Start recording. We have only one visual, so we can just refresh it. And here we are. It takes around 1.5 seconds, 1.5 seconds. I copy the query, launch DAX Studio, and then we start analyzing the code and try to understand what is happening and how the engine is actually gathering this information. Let me just place DAX Studio in the right place. Here it is. I copy the query, and then we gather a bit more space. Also, let's format it. This is the code. You see that the first definition is sales Sparkline. So the Sparkline is defined as an additional measure in the query. And the code of this measure is definitely not easy. There are a lot of rows. And then we have the zero code that is a summarized column by brand and by product, because in the visual we are slicing by brand and product. And then we have sales amount and Sparkline. So Sparkline is the value of a measure. Then as usual we have the top n in order to reduce the number of rows, and then we evaluate with order by. Since we are interested in performance, we are not interested in the top n. I want to retrieve all the rows. Then we take these summarized columns and we place it here. We also get rid of the order by and this variable. Let's reformat the code. So now this is the code that we will understand and we will try to optimize. But in the meantime, let's start enabling server timings and see a first baseline. How long does it take to execute this code? We run it once, and we have our result. We have 4 seconds of storage engine CPU and 1.8 seconds of formula engine. No, sorry, formula engine is 1.1 second, and storage engine is 4 seconds. So there is quite a lot of formula engine involved here. And also there are a lot of queries, but I'm not interested right now in all this performance. I'm basically interested in these numbers. So let me write down them here. We have 4,000 of storage engine, and we have 1124 of formula engine, because this is the original number. Later I'm going to change this code, so we try to see if we can do any better. Now I save this in a window, so in a different one we can start understanding a bit better the code. Let's get rid of this. First of all, what is Sales Sparkline doing? Sales Sparkline needs to retrieve all the points that are required for the Sparkline. So all the points that are visible here, all these values are in some way encapsulated in a single measure, even though there are a lot of points, because the cardinality of the query is still the same. You see that the cardinality of the query is by brand and by product name. We do not have every individual point by date, as you would expect if the number of rows was growing. How is it going to happen? Let's simplify the code a bit. We do have this parenthesis that doesn't look useful. Indeed, it's open there and closed here, so we can get rid of it. That parenthesis and that parenthesis, so that we can reformat the code and we see a bit more of that. What is this measure doing? Well, first of all, it's gathering the values of date. It's summarizing, date by year, month, number, and year, month. Now, I'm grouping by year, month, but year, month is sorted by year, month, number, and that is the reason why we have 2 columns, year, month, number, and year, month. So this is just retrieving the different values of the year, month, number. Then with the second variable data, it's gathering for each category, each of this category, that does have a sales amount, the value of the sales amount. So data contains the year-month number, the year-month, because it's categories, plus the value of sales amount. And that is fine for the rows that do not have blanks there. Now we go straight to the return part. It checks if there is some data, or no, if there is no data, then it returns a blank. Otherwise, all categories computes the same expression that we have seen previously. You see, this part of the code summarize values of date by year, month, number, and date, year, month. That is the same that we have here, but it is being computed in all selected. And that is likely because they want all the points to be the same so that the chart doesn't change the scale depending on the row where it is published. That's interesting. Then out of all the categories, so all the categories contains the year, month, number, and the date and the year, month. And then out of all of them, it takes a sample of 53. Now, sample is not a very commonly used function in DAX. Sample retrieves a subset of a table, taking the first row, the last row, and then a number of rows in the middle, which are evenly distributed in order to reach a maximum of 53 rows. And that is needed because if instead of having year, month, number, we had, for example, the date, that would contain thousands of rows, generating a data set that is really huge. So Sparklines are limited to only a maximum of, I don't remember, 52 or 53 rows. So it's taking only 53 rows from all categories. And then another function that is definitely not very common, substitute with index. Substitute with index takes data, that is the variable containing the categories and the sales amount, and then it's replacing the date and the year, month, number and the year, month with an index in sample categories. So at the end, in sync data, we will no longer have the year, month and the year, month, number, but each pair of year, month and year, month, number will be replaced by a number 1, 2, 3, 4, an index in sample categories. Therefore, sync data will no longer contain the date, it contains just an index and the value. Then out of sync data, we gather the minimum on the y, the maximum on the y, the minimum on the x, the maximum on the x, and then the range, which is the range over y, which is max y minus min y. And I guess we have the range over x. We do not. Okay. Non-blank sync data. Well, what is non-blank sync data? It's filtering, keep filter sync data where the value is not blank, which doesn't seem very useful because if you think about that, this not is blank value is supposing that there are blank values, but we know that there are not because in all categories we check that the values added do not include blank. So actually this part is likely to be useless in my opinion, but it doesn't really hurt a lot. What really looks strange is this part. Look at how the result is computed. Curly brace, then P, then square bracket, and then this concatenate X that is basically iterating over sync data and it's generating a giant string that contains all the different values. Now it's probably useful, and I wonder why I have not yet done it, to run the query and see the result. Here we are. Look at the result. The result contains a curly brace, then P, then 0.33, no, 0,3.3, then 1, 3.5, 2, 5.3, 3, 5.1. That looks like the JSON representation of a set of points enclosed into a string. And it doesn't seem to be the smartest way of generating this dataset, but this is what it is. So actually this result is generating the P, then the square bracket, and then for each row in sync data, you see the values here, another square bracket, then the group index formatted as a number. If it's blank, then a blank, otherwise we format, no, a comma followed by format, and then the division of values minus y divided by range y default by 0. So that becomes the percentage over the range y of the value. So the number that is stored here, 5.1, is not actually the original value. It's already transformed into a percentage over range y, where if it reaches range y, then it's just 1. So there is some calculation that is happening here. Then a comma, and then grouping index. That is 1, 2, 3, 4. Yes, you see the number here, 1, 2, 3, 4, 5. Actually, grouping index, let me understand that a bit better, comes after a comma. No, then there is a y somewhere. No, we have grouping index ascending, and this closes what? This closes concatenate x. Oh no, that is the sorting, sorry. So all this is happening sorted by grouping index. And then at the end, we close the square brackets, and then we add while L, and then we format the minimum y, max y, min x, and max x value. So at the end, we have YL, YH, XL, and XH that provide the boundaries of the values. And then if there is some value, it returns the value. Otherwise, it doesn't return anything. So you have seen this measure basically scans all the possible values. So it gathers in a variable all the values for that single cell of the Sparkline, and then it generates this giant string. That doesn't look very smart. It requires a lot of formula engine, it requires a lot of string manipulation, and I'm wondering whether it would be better, instead of generating this string, to increase the number of rows. So actually increase the number of points in the query, and instead of using a measure, create a more complex query in order to reduce the effort generated by the formula engine and do more calculations in the storage engine. Because the problem of this query is that this value of 1.1 second of formula engine is quite large. For the kind of query that we are running, that's really a lot of time. And besides, parallelism doesn't apply. I'm running right now on a very powerful machine, and even though the data model is quite small, you see that we have some parallelism happening here on the storage engine, whereas the formula engine is definitely not parallel. So what can we do to make it a bit better or different? As I said, I'm not sure that I will actually be able to make it better. And the problem is that if I want to change it, I no longer want the sales Sparkline to be here. I want to run these summarize columns, gather the value of the sales amount, and then add one row per each point of the Sparkline. So I basically need to take this sync data table and append it with generate to the result. So let me play with that a bit. We can keep these summarize columns. We do all that, and we get rid of the Sparkline, and we can use generate. Generate out of summarize columns, and what do we generate? Well, we generate all of this code. So let me copy all of this part. In the meantime, let's also get rid of that. We place it here. That should close generate, hopefully. Yes. Let's see if it still works. Yes. The thing is, I cannot return result as it is. Well, I actually can do something dirty. Let me see if it works. I can take the entire string and embed it into a table just to see that the code is actually working. And it does not. The generate function expects a table expression. What's wrong with you? Generate for each. That actually returns a table. What's wrong with you? Let's go for result. And we pack it into a table. That doesn't work. Two underscores. No way. What if I do row? Doesn't work either. Why that? Oh, because there is this if. If is empty data blank. Yes, there is this if that is creating all our problems. So let's get rid of this if. We just leave this. Okay, now it works. And this didn't change anything. Now I have A as a value, but it is being returned by the query. But it's not working, you see. It's not work. I mean, the values here are all identical. Every row contains the very same values, meaning that we do not have any filter being applied. We probably need a calculate table around everything. And let's see if it works. It does not. And it does not because summarize columns does not keep data lineage. That is the issue. Summarize column returns a result set that contains the brand, the product name, but this is actually not filtering the result. So what I can do is use summarize. Add the columns out of summarize of this stuff. I cannot use rollup at the subtotal, so let's summarize a product by brand. Still no luck. So summarize product by brand, product name. Then I add a column containing the sales amount. Add a column containing the sales amount, and then add columns will keep the data lineage, so I will be able to filter by brand and name and produce my result. Let's see how it goes. Now the numbers are all different, which is my first goal. So I'm computing something that makes sense. And I can also get rid of this measure because we are no longer using it. Now, so far I basically cheated because I am returning in A the same result that I had before. Now I want to expand each of these points into a row, so to increase the number of rows. Remember that my goal is to reduce the formula engine. And it's also good to enable server timing, so we also have an idea of whether this query is now slower or faster than the previous one. And it's actually very close. It's basically the same speed as the previous one. And keep in mind that I'm no longer computing the previous result. This is the first problem that we are facing, and it is solved by the Power BI implementation, while it is not solved by the code that I'm writing. By creating the string, by creating the Sparkline string, with summarized column, Power BI is able to produce the Sparkline not only for each individual point, but also for the subtotals. If we take a look at this report, you see that we have the Sparkline at this level, and these are subtotals at the brand level. And then we have the individual points. Whereas with the query that I created, because I'm using summarized product by brand and product name, I do no longer have the subtotals, and that would create some problems. I mean, computing them would be kind of complex because this context transition would not work in a nice way unless I use the grouping by in summarize. But let's forget about that because these are not expensive. So far I'm returning, let's go at the result, this. Whereas what I want is to increase the number of rows because I want to get rid of this part of the code that for sure will use a lot of formula engine. So a first trial will be to just return sync data as it is. Sync data contains the values, and we can do that here. Instead of returning all this, we can return sync data. And it doesn't work. Why? Because I'm missing an underscore. Sync data. Let me show you the result first. Now, the result you see now, it is very different. We have the brand, the product name, the sales amount, the value, and the grouping index. So value and grouping index, which are the two values stored in sync data, value and grouping index, are now part of the query. It's probably useful to sort it in order to see the values. We can add an order by brand, product name, and grouping index. So the structure should be easier. You see, for a datum, product name, we have the sales amount, the value, and the grouping index 1, 2, 3, 4. So that increases by a lot the number of rows. And actually, it's curious to see that it's slower. It was faster before. Now it uses even more formula engine than it was using before. That's not enough to be depressed because maybe we can make it better later, but it's a sign that something bad is happening. Actually, we are still computing this result. What we could do is, instead of returning sync data, we can use select columns to return the same values that are being computed here, which are the grouping index. So we retrieve just the grouping index. And that's the first we want. Then this calculation, divide values minus min y range, and we call it value. Same expression. Let's see what happens now. Now I should have, instead of the entire content of sig data, I should have grouping index and value. Okay, 20, 52, 57, 42, and so on. And that is computing the same calculation that is happening here. Sort by grouping index, that is not a problem because the sorting is happening at the query. And then we also need to produce this result because that is part of what is needed for the query. So we also need the min y value, which is phase, and then we also need the max y, min y, max y, and also min x and max x. So min x and max x, which are min x and max x. Let's run the query. This is gonna be even slower than before, but now all the values should be here. We have the grouping index, the value, the minimum, max, minimum, and max. And now that I have all the values, we can get rid of this part that is no longer useful. Let's run it and see the server timings. It's slower and slower and slower. It's always slower. Increasing the number of values returned by select columns, it's actually generating a query that is even slower. The thing is, why is it slower? Let's go deeper and see what is happening here. We have this part that is not a... Yeah, we do have a callback data ID that computes this is blank. It doesn't take a lot of time. So it's probably using a lot of formula engine somewhere else. And I need to understand where. We have this summarize, and that is computed by storage engine. Then we have phase that checks for notice blank. Let's check if this is generating the callback data ID. If I run it, my guess is that by running now, this callback data ID should disappear. Either these keep filters or this one. So I first comment out one, and then we see what happens to the callback data ID, just to check whether it's gone or not. And let me see. No, it's still there. We do have the callback data ID, so we can try to get rid of the second one to check whether the callback data disappears. That should reduce the formula engine. Indeed, you see we no longer have the callback data ID. So getting rid of this might be a good idea. The problem is, can we? All categories retrieves by date, the year, month, number, and the year, month, where sales amount is not blank with this all selected. It is not happening here. So actually, these are two different. Yeah, these are two different calculations, and we cannot remove this notice blank. And besides, you see that even though we got rid of the callback that I did, the storage, the formula engine timing is still huge. So this is not going to save any time. Let's see if we can make it simpler in any way. Add column, keep filters. Over categories, notice blank sales amount. Here there's basically nothing to do. Here we have nothing to do because we do have a callback that I did, but it is not that bad. Here we do have sample. Now this sample is going to be slow because for sure it will require formula engine. Formula engine needs to retrieve all the categories and sample the first 53, but it is not going to be slow. And then we have this substitute with index. That might be where I do have a problem. Now this substitute with index is needed in order to compute the grouping index. And it is needed because like in this case I have two columns, the year month and the year month number, that are needed. Actually, all this could be computed without the year month, but that is going to change the code. Then meanwhile, max, these are not complex, there is nothing that can be optimized here, and the same is happening here. So to be honest, I don't think that I can do any better than that. And the thing is, by increasing the number of rows, so by producing a data set that is using 129,000 rows, because we have one row per point, instead of a data set that is using a much smaller value of rows, 2529, the original data set, we start with 1.8 seconds of formula, 1.1 second of formula engine, and we are using 3.4 seconds of formula engine. Therefore, the conclusion is that the choice of using the technique of Power BI Desktop, of Power BI, of creating everything with the JSON representation is definitely not bad. It uses a smaller amount of formula engine. It gets rid of the problem of subtotals. Remember that by rewriting the query, I ignored the problem of subtotals, but my result is not computing subtotals correctly, whereas the query generated by Power BI Desktop is way better because it produces the subtotals. And also, if you think about that, what happens if I add another Sparkline? So let's go here. Let's pretend that I have the sales amount. Let's add the margin too. And let's add for the margin another Sparkline. I can do that. Yes, let's add the margin slicing by date. Let's do it by customer. I have no idea what I'm doing, but looks like by customer. Do we have a customer name? Let's create it. Now this is going to be even slower, but it can be computed. And if you think about that, now the number of points is largely increased because for each date and month and for each customer, I'm computing the value. Actually, I probably made a mistake because this query is going to kill the engine. I have too many customers. So let's get rid of the Sparkline. Let's add another one with a smaller set, like let's go by date and year. Let's create it. Now we do have two Sparklines. One is the sales amount by year and month, and the other one is the margin by year. And if we look at the query, clear, refresh, I would expect this query to have two measures, one for each of the Sparklines. Let's check that by copying the query, format it. And that's exactly what we I don't know. We have Sparkline, sales Sparkline. That's the same calculation we have seen before. And then we have sales Sparkline 2 that uses a different definition for the categories, a different definition for the data, but the structure is nearly the same. We have this scalar key, which had a different name here. Why that? So it renames, in data, it renames date year to scalar key. That is likely because instead of having, before we had 2 columns, now we have only 1 column. Oh, that's interesting, actually. That's interesting. Look at the difference between the first query, that one that is grouping by year, month, number, and year, month, where we grab the categories, so 2 columns, and then the engine needs this substitute with index in order to replace the year, month, number, and the year, month with the grouping with the index. This part is missing in Sparkline 2. If you look at Sparkline 2, data grabs just the date year, renames it to scalar key, and then the value. Then we do not have anywhere the substitute with index part. For each value of the date year, we compute the date year, and then we grab all the categories, we sample them. We use a natural inner join of sample categories with data, min x, max x. So we do have a slightly smaller piece of code, just because we are using only the year. Anyway, the interesting part, the reason why I reached this point is because by using a measure, when you have 2 sparklines, the code is quite simple. You have one measure for Sparkline, another measure for Sparkline 2, and you can increase the number of Sparklines in a visual in quite a simple way. That cannot happen in my query because the way I use generate, I need to compute the first set of rows, but if I need additional rows, either I multiply one by the other, generating a huge amount of rows, or I need to make code that is really, really tricky to solve the problem. Now, before we leave the topic, out of my curiosity, I want to see what happens if I change, because I'm really curious to see that there is a difference in the code when you use 1 column or 2 columns for the Sparkline. So let me clear all this. Let's go back to Power BI Desktop. Let me get rid of the Sparkline, the margin, and in sales amount by year, edit Sparkline. Instead of doing that by year month, we do that by year month number. Year month number is not sorted by, so it will be only 1 column. And of course, I do not have the year month number, so I probably need to enable that. Let's go to date, year month number. Here it is. Let me see if it is the right one. Okay, we make it visible. Then we go here, we edit the Sparkline, and we do that by year month number. Okay, that should be the very same result, no changes, but year month is only 1 column. So let me clear everything, refresh, copy the query, then we go here, we have the first baseline. Let me copy this part so that we do a fair comparison. Okay, enable server timing. So my goal is to check whether using one column or two columns actually produces faster code. And it doesn't work. Why evaluate? There is an error. The syntax is incorrect. This variable, evaluate. I mean, if I replace all this stuff with that evaluate, okay, that works. Server timings. 1.1 second if we use one column only, 1.1 second of formula engine with two columns. Storage engine is nearly the same. Yeah, it's 4 seconds, 3.2, but that is not the number that I'm interested in. The real complexity of the query is all in the formula engine. So actually, despite the code being different, there are no significant differences between using one column or two columns for the Sparkline, even though the DAX code is nearly the same. But the conclusion is that the DAX code generated for the Sparkline is actually quite good, or if you like, it's the best that can be done. Or again, if you like to say it in a different way, I'm not able to make it faster. So, as you have seen, the goal of the video was not to teach you anything. The goal of the video was to learn together. We start by looking at the code, we try to understand what the code did, and we try to optimize it. We try to change it in order to reduce the amount required by the formula engine. The thing is, due to the complexity of the code, if we try to push everything to the storage engine, first of all, we haven't been successful in doing that because sample, substitute with index, this function require the formula engine. And increasing the number of rows in order to avoid the giant string actually didn't lead to any kind of optimization. So even though the code looks complex, it's actually a very good implementation. That idea of embedding a table containing a maximum of 53 values inside the JSON string is quite smart. And it's an interesting technique that I have never seen be implemented in any DAX query before Sparklines. Enjoy DAX!